All right, so the previous videos that we had talked about permutations, talked about combinations, talked about the counting principle, all different ways that we can come up with different things, different ways of choosing things with combinations and permutations and counting principle. That leads us into probability, the chance that something will happen based on different factors. So as we look at probability, one of the first things that we need to talk about is something called the sample space. And what the sample space is essentially, what can I get? What are all the possible outcomes? That's what the sample space is, all possible outcomes. And when we're looking at different sample spaces, we have to be very, very careful to pay attention to order of things and if it matters, whether, say we're flipping coins, does it matter? And that's what we're going to be looking at in a second. Does it matter which coin has heads, which coin has tails? And it does when we're setting up that sample space. And so we're going to take a look at a few examples dealing with coins. So let's find the sample space for tossing a coin, tossing 2 coins, and tossing 3 coins. The first one's pretty easy. When we toss 1 coin up into the air and determine what's going to happen, the sample space is either heads, which I'll abbreviate with just the letter H, or tails, which I'll abbreviate with the letter T. That's the sample space, H or T. There is no other possibility there. All right, that's pretty easy. B, what if I flip 2 coins? When we flip 2 coins, we have to consider that each coin is different. Think of like one is a red coin and one is a blue coin. One is a nickel and one is a penny, something like that. So when I toss those up into the air, it's possible that both coins, both the nickel and the penny, show heads. It's possible that the nickel shows us heads and the penny shows us tails. It could be the other way around. It could be that the nickel shows tails and the penny shows heads, and then it's possible that both of them show tails. And so we end up with 4 distinct possibilities here. I know it looks like these two are the same. It's just one head and one tails, but it matters as far as which coin has the head and which coin has the tails. They are 2 separate things, and so our sample space in this case is 4 different outcomes. Finally, what if we're flipping 3 coins? Well, if we're flipping 3 coins, again, you could think of it, wrong marker, you could think of it as a penny, a nickel, and a dime, right? And so all 3 could be heads. It could be that one of them is tails. Now, if we think of these as being in order, penny, nickel, dime, right? So then each one could be the tails. So it could be heads, heads, tails. It could be heads, tails, heads. Or it could be tails, heads, heads. Right? Those are distinct possibilities because it's a different coin that's coming up with the tails. And since it's a different coin, we have to consider that as a different outcome. It could be that 2 of them are tails and 1 of them is heads. So maybe it's tails, tails, heads. Maybe it's tails, heads, tails. And maybe it's heads, tails, tails. And then finally, maybe all 3 of them come up tails. Tails, tails, tails. So in this case, when I flip 3 coins, we end up with 8 distinct possibilities. Again, it doesn't matter the fact that heads, heads, tails, heads, tails, heads, tails, heads, heads, all are 2 heads and 1 tails. It's different because it's a different coin. Even if we all used 3 pennies, it would still be the first coin, the second coin, the third coin. So it doesn't have to be different coins at all, but we want to think of them like that in order to make sure we get the correct sample space. So, once we have the sample space, from here, that leads us into the next topic, which is probability. Probability, the probability of an event happening, we signify like this. Okay, that means the probability of an event happening, whatever that event is. That's the symbols that we use in math. And the probability that an event will occur, that an event will happen, is equal to the number of ways that the event could happen divided by the number of things in the sample space. Okay, so this is the number, hashtag, the number of ways the event could happen. And then the denominator is the size of the sample space. So it's not the sample space itself. It's how many elements there are in that sample space. How many different things could end up happening. Okay? That's what probability is. And so if I'm looking at, say, 2 coins. I flip 2 coins up in the air, and what we want to know is what the probability is that we get, say, 2 tails. And so, like magic, there's our problem. The probability of getting tails when you flip 2 coins. So according to our definition down here, it says that the probability of something happening is the number of ways that the event could happen divided by the sample space. So when I'm flipping 2 coins, wrong marker, when I'm flipping 2 coins, the probability of getting tails, well, there's only one event that makes tails. When I look at the sample space, there's only one that's TT. And so when I'm doing my probability, that's going to go in the numerator. There's only one event that would be 2 tails, divided by the sample space. If we look at the sample space down below with 2 coins, we could get heads, tails, heads, or tails. That is 4 distinct possibilities. And so the probability that we flip 2 tails when I'm flipping 2 coins is 1 out of 4. We could convert that to a decimal if we wanted to. As a decimal, that would be 0.25. We could convert that to a percentage if we wanted to. That's a 25% chance. Hopefully we have it locked in. We understand percentages and decimals. When the closer the decimal is to 0, the closer the percentage is to 0%, the closer the fraction is to 0, the less likely the event is to happen. The closer that decimal is to 100%, then it is more certain that the event will happen. It is impossible for probability to be over 100%, because again, when we look at the definition, the probability is the number of ways the event could happen divided by the sample space. You can't have more ways of something happening, you can't have that be greater than the size of the sample space, then your sample space isn't correct. So when people say, oh, the probability of something happening is 200%, they're lying to you. It's impossible. It's a mathematical impossibility. The greatest probability that could happen is 100%. 100% means it certainly will happen. 0% means it certainly will not happen. Just to look at one more quick example, instead of flipping 2 coins, different marker, let's say we want the probability of getting 2 heads and 1 tails when flipping 3 coins. So in this case, it doesn't matter which coin has the tails and which coins have the heads. It's just asking us to find the probability of getting 2 heads and 1 tail. So when we do that probability, the probability of 2 heads and 1 tail, based on our definition, means that we are going to count how many ways that could happen in our sample space. So when I look at our sample space, there are 3 different events that are 2 heads and 1 tail. There are 8 total events, and so our probability is 3 over 8. We could convert this one to a decimal just like we did the other one. It's 0.375. We could convert that to a percentage, and that tells us that we have a 37.5% chance of flipping 3 coins and getting 2 heads and 1 tail, not caring which coin has the tails. Let's take a look at another example dealing with probability. So this example is straight from your textbook. In Arizona's the pick game, a player chooses 6 different numbers from 1 to 44. When these 6 numbers match the 6 numbers drawn in any order that is going to come into play, the player wins or shares the top prize. What is the probability of winning the top prize when the player buys 1 ticket? So the odds of winning the lottery, we see that all the time on the news. When the lottery hits a certain amount, people go crazy and start buying tickets. What is the probability that it wins? So if we have 44 different numbers, order doesn't matter. It doesn't matter if the lottery comes out to be 1, 2, 3, 4, 5, 6, and I have picked 6, 5, 4, 3, 2, 1, I still win. I don't have to have the correct order. That would be even more difficult if you had to pick the correct order. And we'll see that as we go through this problem. So, first thing we need to do is we need to figure out the sample space. How many different combinations are there of choosing six numbers out of 44? Well, thankfully, you've already watched the video, and if you haven't, go back and watch the video on choosing things. That is just going to be a combination. So our sample size is simply going to be the combination of 44, choose 6. It's a combination because it does not matter what order we get them in. We talked about that in the last video. And so we know what this is going to end up working out to be. When we do the combination rule, if you watch the last video, you'll see that is going to be 44 factorial divided by 44 minus 6 factorial times 6 factorial. Right, that 6 factorial gets rid of all the repeats. And so if you work that out, and I've already done all of the math to work that out, actually the book did all the math to work that out, but I did verify it, 7,059,052. That's how many different ways that we could choose 6 numbers out of 44, not caring about the order. Care about the order, that number goes way up, right? If we didn't care about the order, we wouldn't be dividing by the 6 factorial. 6 factorial is 720, so basically take that answer and multiply it by 720. That's how many possible outcomes you could get if order does matter. Getting 1, 2, 3, 4, 5, 6 is different than 6, 5, 4, 3, 2, 1. So we have that many different possibilities to get the winning ticket. The probability of winning, get the right marker, the probability of winning is simply going to be the number of ways that you can win divided by that number. So how many ways can we win? Well, we have to get the right 6, and there's only one set that's going to be correct out of the 7,059,052 different possibilities. And that's the probability of winning this lottery. Just for funsies, that decimal, 1, 2, 3, 4, 5, 6 zeros, then a 1, and then a 4. That means that you have 14 chances out of 100 million possibilities. That's not a high number. Right, you don't have a big chance of winning the lottery. That's something that we should instinctively know, but that's the probability. It's a very, very small probability. In our next video, we'll be looking at the probability of 2 different things happening, the probability of 2 different sets, what happens when they overlap, and what happens when there's no overlap of those 2 sets. So that video watch as well, and then that will end our probability unit. Until then, have yourselves a great day.